Welcome back to another episode of Program That Part. Today we are going to program this part right here, and this is a shifter knob for a Ford Fiesta ST or Focus ST or Focus RS, and this is one of the simplest ones that I have ever made. And basically this stock outside here, or the stock piece I'm using is a regular stock size piece. It's 1 3/8 inch in diameter, and so I didn't have to cut anything to size or anything, so it worked out really well. So basically how I have this set up is this one right here is the top side and this is the bottom side. So we'll have to pocket this out and we'll end up threading this deeper hole right here by hand with an M12 by 1.25 tap. Now this is one of those things when I first started, so please forgive me if anything looks kind of weird. Starting with this facing operation, for some reason I'm doing a lot of step overs here and I'm using the shear hog, but I have no idea why I decided to step over so many times. I have a 0.06 step over it with a 3/4 of an inch end mill. Anyway, we'll roll with it. 4,000 RPM at 35 inches a minute, and I selected this chain right here. It doesn't really matter what you select in a facing operation because it'll just bring it down to the model top here. So it always uses this model top as your bottom height by default with a facing operation, as far as I know. All the heights here are pretty default, and I used a 0.06 of an inch step over. I really didn't need to do that, but that's okay. I could probably go somewhere more like 0.1, and even then it probably wouldn't be enough, but that's okay. And everything here is left alone. I almost forgot the setup here. 1 second while we go back to the setup. So this stock is looking at both of these bodies here, so that's why it's 4 3/8 wide. It is 1 3/8 in depth in the Y direction, and that's just the diameter of the part, and it is 3.85 inches tall, so that's how tall each stock piece of these parts are. So in this setup I'm using these soft jaws here, and this is my point. There's no two work coordinate systems. This is my point right there on the side of the soft jaws, and that's a reoccurring theme with me. I usually use that point right there on all my soft jaws. So after I face, I'm going to go in and adaptive everything out right here. Using a 1/4 inch flat end mill at 6,000 RPM, 30 inches a minute, I'm going to select this right here, this boundary chain, which is that green chain right there, and I have rest machining selected for no reason because it's always from the stock setup. So that doesn't really need to be selected there. And from this boundary chain, I have tool center on boundary. So you can see in the dialog box here what that really does. And those dialog boxes help a ton when you're trying to figure out what the toolpath does. In the heights tab, it's just pretty generic here. Nothing too big going on because this is a regular 3D adaptive toolpath, so it just knows what's going on wherever. It's kind of cool how it works out, so you don't really have to do too much with those, is what I found out. And our width of cut or optimal load will be 50 thousandths of an inch. That stays the same. My roughing step down will be 0.13 inches, and my fine step down will be 0.1 inches. I'm leaving 10 thousandths of an inch radial stock to leave, so that's on the sides, and I'll come back and clean that up later. And everything on this tab should remain the same, except this right here, 0.1475 helical ramp diameter. So after I click out of here and click it, the red mark right here, that's the helical ramp diameter, and that needs to be a lot smaller so it can get down into this pocket right here. Because if it was any bigger, then the tool would be hitting the side. It would actually give you an empty tool path, so that's always annoying. So watch out for that on your 2D adaptives and regular adaptives. Always remember that your helical ramp diameter needs to be small when you're doing those smaller pockets like that. And next up, to clean out that pocket there, is a pocket toolpath. Using the 1/4 inch end mill again, 5500 RPM at 25 inches a minute, I am going to select this whole area right here, this big pocket. And in the heights tab, the top height is this right here. So I changed this top height to this face right here because everything else has now been machined out to that point. So I don't want to waste a whole bunch of time coming up here and trying to ramp down to that point where there's some material to cut. So everything is left alone. In this area right here, I'm going 0.08 inches deep, and that doesn't sound like a lot, but I'm cutting on all sides here. I mean this cutting all the way around, so it's a little bit rough for this one. So multiple depths, 80 thousandths of an inch each depth. And I'm leaving no stock to leave, but it's check marked for some reason, and it doesn't need to be check marked because it already says 0. And everything is pretty much left the same up here, except on this area I'm using a 0.5 degree ramping angle. So this is very shallow, and that's just so I can get a nice gradual cut into the material rather than hardcore, because that'll slow everything down. Since I'm cutting on all sides, that just makes everything a lot harder to do. So that's why I'm going so shallow on the ramping angle. So that's the only thing that really changed right here. And you'll see what kind of toolpath this gives us. Let me turn on wireframe. You see we're barely ramping down until we get to that 80 thousandths of an inch deep from this point right here. You can sort of see it from the top of that face. 80 thousandths deep is that blue line, then it'll clear everything out for a second and then start ramping down again and again and again. And that's how we get that toolpath. And next up is a pretty cool toolpath. You can see the tool I'm using here. It's a radius tool. Not a whole lot of people use those. It's kind of cool how they work. And this took some trial and error to get the right depth, so you're not cutting in up here on the tool. But we have this 1/4 inch radius tool, so this radius right here is a 1/4 of an inch. We're running this thing at 6,000 RPM at 27 inches a minute. This was always frightening to use this thing for some reason, just because it was so big and bulky. So I selected this chain right here, and that's to bring basically the nose of the tool to this point and machine around it. We'll go back to the toolpath so you can see what I'm talking about. So you can see right here where the middle of the tool goes. So I'm going to do one pass around and then the final pass. And that's just to prevent a whole loading up of the tool and all that kind of stuff. So that's why I'm doing 2 passes here. So this is what took some trial and error. After doing this a few times, I found that if I select this edge, so my bottom height right here, I selected this edge, and I'm going negative 65 thousandths below that edge. So that's why it looks like it does. It's 65 thousandths below this edge, and that's what I found is the best way to go for this tool. And that gives me the best radius here on the actual part itself. So that's ultimately what I went with. So everything up here is left alone, and I'm selected roughing passes, and each step over is 50 thousandths of an inch, and I'm just doing 1 step over. So that gave me that 2 toolpaths there that you already saw. And then everything on the linking tab is the same. So next up, I'm going to use my 90 degree spot drill, 1/4 inch spot drill, 7,000 RPM at, well, that should have been like 35 inches a minute, but no big deal there. And I'm going to select this point right here. And there's no stock left there yet because the adaptive only got down to this point right here. So we're going to cut out some material right there to make room for our drill, to drill out this hole to size to be tapped basically. Using this tool, 7,000 RPM at 35 inches a minute, or it should be 35 inches a minute, I selected this point right here, that center point, and to select that point, I select this circle right here, and that gives me that point, and make sure you have selected points selected. And for the top height, I have this face right here selected, just a little shelf looking thing there, and the whole bottom is, after I selected this, that thing sits the whole bottom, so I'm going 50 thousandths below the whole bottom. So after I selected this circle right here, it gave me that point, that thing sits the bottom. So I'm going 50 thousandths of an inch below that. And then just really, real quick, drilling rapid out. No need to peck or anything like that. And next up is the chamfer. We're going to use the 90 degree spot drill again, 7,000 RPM at 20 inches a minute. Again, that could have been a lot faster, but this is in my early days. And I selected all of these points right here and left everything here on the heights tab. And the chamfer width is 5 thousandths of an inch, and everything else is left the same. And next up, I use the spot drill again to trace my logo in the top of this shift knob. And we'll turn on wireframe so you can see what that looks like. So that's what it looks like there. And from the dog bone video, I used this DXF image vectorization tool online to get my logo. And in the model tab, you can see here I have my logo all right here. It doesn't matter, it's kind of upside down, but This is the only thing that really matters. I just imported it and put it on this face here. And John Saunders has a bunch of videos from a while back where he did this actually, and it's pretty cool how it works. So I ended up doing that, and I selected this part of my logo here, and that gave me this tracing operation. So go here, and I'm using the 90-degree spot drill at 8,000 RPM, 20 inches a minute, and I selected that part of my logo here. And that'll just trace out everything that it sees here, and it looked pretty good after I did it the first time. And everything on this tab is left the same, and on this tab, chamfer doesn't need to be checked, but the axial offset. So this axial offset is how deep the tool is going to go in the material. So I'm going 10,000 7-inch deep. That is pretty deep for this type of thing, but it ended up looking fairly well, and I always kept it, so I never messed with it again after that. Maybe a little bit of light sanding after it was machined is what made it look the best. And then everything on the linking tab is left the same. So now I'm going to come in with a 17/64 drill and basically pre-drill out this big hole here. And you can see it, how deep it goes. It goes 70 thousandths of an inch below the hole bottom. So I selected drill tip through bottom, and then I went an additional 70 thousandths. And then everything else was left the same on this. So this tool, like I said, is a 17/64 drill, running at 3,000 RPM and 10 inches a minute. And I selected this point. I selected this face actually on this one. That's different. I'm not sure why I did that. Anyway, I selected this face, and then it'll give you the same thing. It'll just give you, it knows where the whole bottom is after you select the face. No big deal there. And I'm using a full retract cycle on this. So at 80 thousandths of an inch is what I'm pecking, and it will retract the full length of the hole each time. So it takes a little bit longer, but it gets the chips out of there real nice. And then that'll make room for the big drill. This is a 27/64 drill running at 4,000 RPM, 1.1 inches a minute, and this is back when I really had trouble drilling. So, I mean, it's been a while since I've made these. So 1.1 inches a minute is what I went with, and this was probably with a hardware store drill, so that's why it really sucks. So I selected that face again, basically this whole cylindrical face here. Select it again right there like that. And the heights, I did the same thing here. Put the drill tip through the bottom and added another 70 thousandths of an inch. And I'm using another full retract deep drilling cycle here at 0.0125 inches. So this was, like I said, back when it was a rough time drilling. But now at this point I have much better tools and everything like that, so I've always bumped this up. I just haven't made these in a while. And lastly, I made some, I like to call these piston shifters, and in pistons they have the ring lands where the rings are set in the piston. So I wanted to make some cool contours here and make all three of them for each, resembling each of the three ring lands that a piston would have. So I basically faked out Fusion 360 and told them that this was a slot. This is not a slotting mill. So this is what I told him it is, but it is actually a thread mill. I gave it all the dimensions of my thread mill, 0.3 inches in cutting diameter, and gave it the rest of my specifications for that thread mill. Except now in Fusion 360 it looks round and looks like a slotting drill, or slotting mill. But what we actually used was a thread mill, and that cut those sharp corners in there. So at 7,000 RPM, 30 inches a minute, we selected these points here, and those are sketched in circles. So as you can see, these maroonish looking marks, I basically sketched those in and brought those circles in as far as I could so I could select a contour to make this tool go to that point. And that's pretty much how it worked. So once I selected those points there, you can see all three of them. And let me just show you the tool path really quick because, yeah, so that's the center of the cutting tool there. It'll barely just touch around the circumference of this shifter handle here, and that'll make a cool little tool path, and I'll show it in the simulation here in a second. So I didn't touch anything on the heights tab, didn't touch anything here on the passes tab, and everything on the linking tab is the same as well. So basically just selected those and selected my tool and let it rip. So here is what it looks like in the simulation. And here is the simulation. Coming in and facing and pocketing out on that right side one. Fixing that up. So on this, it thinks the top of the radius tool is lower than it actually is. So it's not, I'm confused on why Fusion thought that. It's not a big deal because I can clearly see that the top of that radius tool is not hitting the top of the stock, but it thinks it is, and it's giving an interrupted piece here, and it's just kind of crazy. But that's no matter, it didn't do it in real life, so it doesn't matter. So now it'll come in and do the engraving here. And the drilling. And next up is this contour. So there you go, right there. It'll just barely touch around there. And these aren't rounded like you see here, they'll be sharp because it's a thread mill that's actually cutting this. So it'll go around, and that's what it'll look like after it's finished, except actually kind of sharp. And these will be a little bit skinnier than you see here. So that is it. Pretty cool on this one. This was like one of the first shift knobs I ever made, besides the pistol grip shift knob. And I really enjoyed making it. It's one of the first things I ever made. But if you have any questions, leave them down in the comment section below, and I will be sure to get to them. Thanks for watching.